So you can download the world's most powerful new AI model entirely for free.
Right, but having the key to the door doesn't mean you can afford the house behind it.
Yeah, that is very true. Welcome to the deep dive. Today we're exploring a fascinating new AI model called Kimi K3.
And man, it is generating a massive amount of hype right now.
It really is. It's a 2.8 trillion parameter behemoth that Moonshot AI just open sourced.
Which is an incredible software achievement, honestly.
Absolutely. But we'll unpack what it really means when an AI of this scale is labeled open weight,
Yeah.
because we need to look at the staggering hardware reality required to run it.
Oh, yeah. The physical reality of this is wild.
We're going to look at the eye-watering financial cost and why you might just want to use the API instead.
People see the word free and immediately start planning how to run it on their desktop.
I totally get the impulse. Though I have to admit, I still wrestle with prompt drift myself. So the idea of managing a literal data center just to talk to an AI is intimidating.
Well, I mean, it should be intimidating. We aren't talking about a lightweight app here.
Let's start with the model itself.
Yeah.
Moonshot AI released Kimi K3, and they really delivered on the promise, right?
Yeah, they shared the weights, the configs, and the inference code. It's all sitting right there on Hugging Face.
And for those listening, Hugging Face is essentially the central hub for open source AI, so the access is very real.
Exactly. It's not some walled garden. You can technically run it on your own infrastructure right now.
Right, that's the software promise. But then we hit the brutal wall of physical hardware.
The scale of this thing is genuinely hard to comprehend.
We're talking about 2.8 trillion parameters.
Which is massive. A parameter is essentially a tiny mathematical weight. It's like a single connection in the AI's artificial brain.
So having 2.8 trillion of those connections translates to a lot of physical data.
Oh, definitely.
I checked the Hugging Face repo. The total file size for Kimi K3 is 1.56 terabytes.
Whoa. I mean, imagine downloading 1.5 terabytes just to say hello to a model.
It's mind-bending. Just
Yeah.
pulling that down on a home internet connection would take days.
And once you download it, where does it even go?
Right. Most standard laptops don't even have a 1 terabyte hard drive anymore.
You literally cannot fit the basic files on a normal computer. A team called Atomic Chat actually tested this.
Oh, they downloaded the full weights?
Yeah, just to see what they were dealing with. They noted it took up 1,454 gigabytes.
Just sitting idle on a drive.
Exactly. It
Yeah.
just sits there like a massive digital boulder.
But I know developers try to shrink these models using quantization. Does compressing it with quantization actually solve the problem for a normal laptop?
It helps, but no. Just to clarify, quantization is shrinking the AI model by using less precise math.
So you sacrifice a tiny bit of reasoning accuracy to save space.
Right. A group called Build Fast with AI tried this. They used an MXFP4 quantized version.
Did it make a significant dent?
It did. They actually got it down to 594 gigabytes.
Which is still absolutely massive.
It's huge. Hundreds of gigabytes is still way beyond consumer limits.
So quantization just takes it from impossible to extremely difficult.
That's a perfect way to put it. You're upgrading from a bicycle to a scooter, but you still can't tow a semi-trailer.
Okay, so I could buy a massive external hard drive, but storage is just sitting data.
Yeah, storage is just step one. Active memory is the real bottleneck here.
It's like a workshop. The hard drive is the dusty shelf in the back, but the active memory, the RAM, is your workbench.
I love that analogy. And your standard workbench is not going to cut it. A normal Mac or gaming PC is completely out of its depth.
Gamers usually think they have powerful rigs, right? Like an RTX 4090 with 24 gigabytes of VRAM.
Kimi K3 laughs at 24 gigabytes. You need VRAM just to load those initial weights onto the workbench.
And that's just the first hurdle.
Right. Then you hit something called serving memory.
Loading the model is just waking it up. Why exactly does the memory requirement spike so much once you start actually talking to the model?
It all comes down to the KV cache. That stands for key value cache.
Which is essentially the AI's short-term memory for remembering your current conversation.
Exactly. Generating responses requires holding past context actively in the GPUs, and it compounds incredibly fast.
Right. The longer we talk, the more memory the AI eats.
Yeah. Let's look back at that Atomic Chat test. They used a VLLM setup to manage the memory.
How much VRAM did they actually need?
Around 1,680 gigabytes.
Wow. Let that sink in. 1,680 gigabytes of active video memory.
To get that, they had to use 8 NVIDIA B300 GPUs.
Those are top-tier enterprise chips.
The absolute bleeding edge. Those 8 chips gave them over 2 terabytes of total memory.
Just to fit the smallest viable setup for the model.
Without crashing, yeah.
So if it takes 8 enterprise-grade GPUs just to wake the model up, we have to look at the financial damage here.
The economics completely shatter the illusion of free open source.
We have to compare self-hosting the hardware versus renting it in the cloud. Let's start with owning it.
You're not just buying graphics cards. You're buying specialized servers, heavy-duty networking, industrial power.
And massive cooling systems.
Right. 8 B300s running hot will melt a normal office closet.
It's like buying a whole restaurant because you want one dinner.
That is exactly it. You're buying walk-in freezers just to make a sandwich. It makes no sense for an individual.
So most people look at cloud GPUs. They just want to rent the kitchen for an hour.
Which is the obvious next step.
Atomic Cat rented their setup on vast.AI, right? 8 B300 GPUs. What was the hourly cost?
It was about $85 to $86 per hour.
Per hour. That adds up terrifyingly fast.
It does, but here's the wild part. It costs $100 to $120 from an empty instance just to get the setup working.
Wait, before you even run a single prompt?
Yep. You rent the machine, then you spend over an hour downloading 1.5 terabytes and loading weights into active memory.
And you're paying $86 an hour to watch progress bars. So renting the cloud GPUs is a trap if you just want to experiment on a Sunday afternoon.
It absolutely is. The billing meter starts the second the instance boots.
So the taxi meter runs while you're still building the car.
Perfect way to describe it. Troy McCann actually made a really funny joke about this on X.
Oh, I think I saw that.
Yeah, he pointed out that you need a $500,000 upfront setup or a $35,000 monthly GPU budget.
Just to avoid paying for a $99 per month Kimi K3 subscription.
Exactly. It really puts the open label into stark perspective.
We're going to explore who actually benefits from taking on this massive financial burden right after a quick word from our sponsor.
Stick around.
We'll be right back.
All right, and we're back.
So before the break, we talked about that $35,000 monthly barrier to entry. It begs the question, who is actually walking through this open door?
It's a very exclusive club.
There has to be a break-even point somewhere. Let's look at enterprise users and research labs.
Research labs are a great example. There's an academic group called LM Cash Lab doing exactly this.
Why do they need this massive headache instead of a cheap subscription?
Because they need total granular control. They have to manipulate the weights, adjust the precision, and monitor the serving environment.
You can't get that from a commercial API.
No, an API is a black box. You ask a question, an answer pops out. Researchers need to see the gears turning.
So for a lab, a B300 cluster is just a basic scientific tool.
Just like an electron microscope. Expensive, but fundamentally required.
What about AI infrastructure teams?
Places like Red Hat AI, they already have the clusters built out.
They own the server racks and the industrial cooling.
Exactly. For them, Kimi K3 is just another workload on an 8 by B300 node.
It's not a new $1 million investment, just deploying software on metal they already own.
It's just a Tuesday for them.
And then we have the high-volume companies, businesses building consumer products on top of these models.
Kimi Klein is a fascinating case study here. They build an AI coding assistant.
Their token usage must be absolutely astronomical.
It is. Their inference cost for Kimi models was hitting roughly $3 million per year.
Wow. $3 million a year just on tiny API fees.
Right. And at that scale, comparing API costs versus buying servers becomes a real math problem.
At what point does a company like Klein decide to take on the massive headache of self-hosting?
Right around that multi-million-dollar mark, buying the hardware finally becomes the cheaper evil.
When the API bill hurts more than hiring a server team.
Precisely. You take on the hardware burden to stay profitable.
But if you aren't spending $3 million a year, how are you supposed to actually use this incredible model?
You rely on the pragmatic alternatives. You definitely do not try to build a data center.
Let's talk about everyday developers and learners. How should they be interacting with Kimi K3?
The simplest answer is the best one. You use the official API.
Moonshot AI provides that exact service. You pay per use, and they handle the servers.
They manage the complex B300 clusters, the cooling, all of it.
There's a great anecdote about a solo developer who used it.
Oh, the guy who built the game.
Yeah, he built a CSGO and Portal-style game using Kimi K3.
He pumped a massive amount of code generation through that API.
He used 600,000 tokens for that project.
And his total bill was exactly $3.24.
That is just wild. Compare that $3.24 to the $100 it costs just to boot up a rented cloud instance.
It's a no-brainer. The economics heavily favor the API for small projects.
Are cloud GPUs ever useful for smaller teams then?
Only for strictly short benchmarks. Or testing if your enterprise needs to self-host eventually.
Just to test the waters.
Right. You run your stress tests for an afternoon, then you shut it down immediately.
Never leave it running overnight.
Never. But what if someone really wants local privacy?
They don't want company data going out to an API.
Then you have to compromise. Pick a smaller model that actually fits inside your laptop's RAM.
Because you fundamentally cannot run a 2.8 trillion parameter model locally.
Exactly. You sacrifice some reasoning power for complete privacy.
So for solo founders, avoiding the API in the name of open source is actually self-sabotage.
It really is. Managing hardware clusters distracts from actually building a product.
The API gives you the genius without the IT headache.
Spot on. You want the brilliant answers, not the chores of keeping the machine alive.
Let's slow down and recap the big idea here. Kimi K3 is genuinely open weight, which is a massive triumph.
It's a huge contribution from Moonshot AI.
But open is a software term. In the physical world of hardware, taking advantage of that freedom requires a massive GPU cluster.
You need literal tons of metal and millions of dollars.
So if you're listening, check out the API if you want to play with Kimi K3 without taking out a second mortgage.
Seriously, your wallet will thank you.
Think about this as we wrap up today. If the most powerful open knowledge in the world requires millions of dollars of hardware to unlock, are we democratizing AI? Or are we just shifting the monopoly from the people who write the software to the people who build the microchips?
That's the real question we have to figure out.
Thank you so much for joining us on this deep dive. We will catch you next time.